All right, hey, let's take a look at the graph of the sine curve today. So this is a topic that a lot of students learn in either their trigonometry class or pre-calculus. And sometimes all these transformations kind of throw the students for a loop. So I'm actually kind of surprised I've never made this video before because this is a really common, important topic. And I've tutored a lot of students in this topic this year, in fact. And I used to teach a trigonometry course at high school, so I went through this in detail with them as well. So I put together, I think, 8 or 9 questions that we're going to be looking at in this video. Just getting progressively more difficult, covering all the different types of transformations that you can encounter. So hopefully you'll pause the video and give the graphs a try after I go over these first couple and see what you can do with this, because it's not hard as long as you can follow my instructions on finding the magic 5 points, So stick with me so you can understand what I'm talking about there. It will make it so much easier. I always see that light bulb just go off in the students once they start to realize the pattern. Okay, a sine curve. You have been working with unit circle, I bet, and you understand that sine is that y over r, the y coordinate on the unit circle. And of course, the unit circle goes all the way around, right? I guess I should draw it this way. It goes all the way around, and eventually we get back to the beginning again, and it starts over. All the values start over again, like, the sine of 330, or let's say that 390 degrees is the same as the sine of 30 degrees, right? Which is just 1/2. So really easy. It repeats itself. That means the graph is going to repeat itself. It's cyclical. It does its thing, and then it just keeps doing the same shape over and over. So it's periodic or cyclical in nature. And we also call that sinusoidal. So the graph is an example of a sinusoidal curve. I'm only covering sine in this video. I'm not going to cover cosine. I'll do that in a separate video, even though it's the same curve. I didn't want to try to do too much in this one video. So I really just want to hone in on the sine curve. All right, so you're thinking, gee whiz, come on, get to it. All right, so the sine curve has what we call a period of 2 pi. So what does period mean? It means how long, if you think about that x-axis, which is this guy right here, as being time, how long does it take for the graph to start and finish? So if we think about 0 as being the start, and then 2 pi is the end, that's when it's going to start over again. And we've come 360 degrees, because after all, how many radians is 360 degrees? 2 pi. So the sine starts to repeat again after 2 pi. Now I'm going to subdivide this, where this is pi. This would be half of a pi, right? And then this, of course, would be 3 pi over 2. Now, if you look at your unit circle, how big does the y value get at its absolute largest, just on the unit circle? It goes as high as 1. And then, at some point, I think it's 270 degrees, or 3 pi over 2, it goes all the way down to -1. So I accidentally put a little minus sign there. I was talking and writing at the same time, so I messed that up. All right, so this graph goes as high as 1. For this one, I'm going to put these little dotted lines, and as low as -1. Now, what is the sine of 0? If you look on your unit circle, where does this thing, quote, start? That's what I always ask students. Where does sine start versus where does cosine start? So sine starts at 0. So at 0 degrees, or 0 radians, sine is 0. So I'm going to let me change colors so they stand out here. I'll put a nice big blue dot there. So that's one of my magic 5 dots that we need to figure out. All right, so where does it end? Right where it started. So this is always the second dot I do. So here's number 1. Here's number 2. All right, what is number 3? Well, right in the middle is when it's at the middle again. So if you look at pi, go 180 degrees on your unit circle, the y-coordinate is 0 there. So this is usually number 3 that I would draw. And then, what is the sine of pi over 2? It is 1. It goes as high as 1 right there. And then the sine of 3 pi over 2, if you look on your unit circle, is down here. So here's my magic 5 dots that will really help me graph this. Now, I know it kind of looks like this, right? But that's not what the graph looks like. The sine curve at the very, let me use a different color here, at the very tippy top, it actually goes horizontal for just a moment, okay? And then when it's cutting through right here, it actually cuts through at a 45 degrees, so it doesn't go vertical. A lot of students draw it like this, like they go 100% vertical, and that's not the case. So I always like to point out to students it actually goes it goes at a 45. So right here is going to be another 45 when it cuts through this spot. And then it goes down here, bottoms out at -1, and then it's back to here again. That's called 1 period. 1 period. Now, I got sidetracked here. I wrote here that the period was 2 pi. There is a thing called the amplitude. It's how high and how low this thing. Like if you turn up your amp in your car, it stretches this way all the sound waves so that they get louder. Okay, makes them more pronounced. It doesn't stretch them this way because that would change the frequency of what you're listening to. You don't want that. You want it just to be louder. You want it to be stretched this way. So the amplitude is 1 here. Why 1? Well, you might be thinking, what if this is like 2, right? Well, it's up 1, down 1, up 1, down 1. So that's what the amplitude is it just means that it goes up 1, down 1. But amplitude is always positive. You don't have to put the plus sign there. But the amplitude is always positive. In this case, a plain generic, or sometimes I call it the plain vanilla sine curve, has an amplitude of 1 and a period of 2 pi. And then it just keeps going, by the way, folks. It just keeps going. And over here, it would just keep going. It goes up and down, up and down. Just like, for example, the sun and the earth and the amount of daylight we have in each day follows this curve right here. Is a great example of that. So you got to know this one really well. This is the plain vanilla sine curve. Now we're going to start transforming it in all the different ways. Okay, so let's continue on. Example number 2. What does a plus 2 do at the end of any function? Think about y equals x squared. That was a parabola, right? Look kind of like this. What happens if you throw in a plus 2 at the end? It just moves the graph up by 2. Okay, so let me get rid of all that now. I was just trying to remind you with a parabola, what does it do? This is called, some teachers call this the midline. It's the middle of the graph. So go up to 2 on your graph paper and draw a dotted line, literally to help center yourself. So you're nicely centered on 2. Y equals 2. So it's a vertical shift. Let's write that down. Vertical shift by 2. A lot of worksheets that I've seen have the students write what is the period, what is the amplitude, what is the vertical shift, what is the horizontal shift, and all those sorts of things. What is the horizontal stretch? And we'll talk about all of these things here in a minute. Is there any reflection? All right, are there any other things going on in here? Well, no, this is just a 1x, so that's good. And then there's just an invisible 1 here, just like there was for my plain vanilla graph. So just like the last one, we're going to do our 5 dots, our 5 magic moments. So where does the sine curve start? The sine curve starts in the middle, right? And then it goes up and it goes way down and then back up here and it hits the middle, and so we've got this middle, this midline. So this is going to start at the middle. Now, how many regions of the graph are there? There are 5 magic moments here, 5 magic dots, but there's 4 quarters. 1, 2, 3, 4. Those are the regions of the graph. If you think about the quadrants, I couldn't think of the word for a moment, the quadrants of the unit circle, the 4 quadrants, and then it starts over again. The reason I bring this up is because we need to go 4 quadrants, leave 4 quadrants. Here's 1, 2, 3, 4. 4 quadrants of the graph. So I'm going to go right here and put my second dot. Remember I said this was the first dot, this was the second dot, and then we go to the middle there and we put our other dot. And then what is the amplitude here? The amplitude is 1. By the way, I didn't say this. The period in this is 2 pi, just like a plain vanilla one. So that's why I would come down here and I would label this 2 pi. This would be 1 pi. This would be a half of a pi. And then this right here, of course, is 3 pi over 2. I can zoom in here for you. This would be 3. This would be 1, by the way. Now the graph goes as high as 1 and as low as -1, usually. So this is up 1, down 1, up 1, down 1. So we start on our midline and we go up 1 and then we go down 1 over here. So I've formed that shape right there again, and I can go ahead and draw in the actual curve, trying to not make it too ugly. And then you just continue the pattern. So this thing just keeps going like this. You could even continue it over here. Whoops, that was pretty bad. I'm going to try that again. And so on. So there's your sine curve with a vertical shift of 2. Okay, so let's go on to the next example. There's a lot to go over, so don't bail on me yet. You got a lot to learn. What about a number out front? Let's go back to our example of y equals x squared. Here's x squared. Looks like this. What happens when you throw the number 3 in the front? You remember what that does? It's a vertical stretch. So what used to be at 1 is now at 3. So the graph now looks much steeper, more narrow, but it's a vertical stretch. This is amplification. This is amplification right there. All right, so I'm going to erase that so we can do our sine curve on here. So our period, our period is still 2 pi, and we'll talk more about how we can change that here in a moment. So that 3 out front, that is our amplitude. Amplitude is going to be 3. This thing is going to be stretched by a factor of 3. So otherwise, this is a plain vanilla graph. There's no change in the period. There's no vertical shift or anything like that because I didn't put any number out there just yet. I didn't want to double up just yet. So we're going to still start at 0. We're still going to finish after 4 quarters, after 4 quadrants. All right, and we're going to hit this in the middle also. But this time, instead of just going to 1, it's going to stretch all the way up to 3 this time. And then, instead of just going down to -1, this is going to stretch all the way to -3. And then we can draw our curve. And of course, we could keep doing that pattern. If our teacher, sometimes teachers ask to graph 2 periods. All right, so you just keep doing the pattern as long as you'd like and just keep going. All right, so there's a sine curve, a sinusoidal periodic curve that keeps repeating that's been stretched by 3. Think about, I don't know if you have like a science museum where they have a giant pendulum that's swinging back and forth. Imagine pushing that and then giving it a really big push. It's going to go further out. So it's going to go all the way to 3 and then back to -3 because you gave it a bigger push. All right, moving on. What happens if there's a number on the inside of a function? Well, this will change the, let me put it here, affects the period. Affects the period. All right. So here's a lot of textbooks call this b. This number, this coefficient in front of the x is b. And the way I always told my students is you take the 2x and you set it equal to 2 pi because that's how long it takes a normal sine curve to finish its thing, is 2 pi, right, as far as time goes. Well, this graph is going to, listen carefully, this graph is going to be 2 times faster. Because if we divide by 2, we get x equals pi. It's twice as fast. It's faster. That's how I like to think about this. And when I say that to a lot of students, their eyes light up and they say, oh, I get it now. That 2 is a horizontal shrink. It's going to be faster, twice as fast. So, again, I like to put a dot here. It's still starting at 0. And I'm going to say it's going to end here, but this time this is pi, not 2 pi. This is only 1 pi. And that means the middle would be pi over 2, right? Half of 1 is a half. Now let me zoom in here. This hash mark right here is going to be pi over 4, a quarter. And then this would be 3/4, 3 pi over 4. And then we can fill in the rest because I didn't do anything else here as far as transformations when I designed this presentation just for you. So this goes up 1, down 1, up 1, and so on because the amplitude here was still 1. So the period was pi. The amplitude was 1 though. So it goes up 1, down 1. All right, so when there's a number on the inside, it affects the period. So 2 times x means it's going to do its thing twice as fast, which means the period will be half as long. Hopefully that makes sense. All right, now let's start ramping things up. What does a minus sign do on any graph? It flips it over. So normally our curve would look like this. When we get done here, it's going to be flipped over. It's going to look like that. So it's going to start by going down. But it's still going to have its 5 magic moments that we're going to fill in here in a sec. So that's what that does. This is a reflection. You knew that. That's a reflection. What about the period? That quarter, that's what that is. That's quarter, right? This is 1/4 x. When will that finish? Our b value this time is 1/4. So if you multiply both sides by 4, oh my goodness, look, this is a major drag. This is going to take forever to finish its period. Okay? This is the period. The period is 8 pi on this graph. So it's going to start here, and then I'm going to go 8 blocks, I think. So I really need one more, don't I? This will be 8 pi over here. So in the middle would be right here. This would be 4 pi. Right here would be 2 pi. Right here would be 6 pi. You see how I'm just slicing and dicing my curve. Notice those middle, those 1, 2, 3 are all the same. That's these guys right here. But instead of going up, it's going to go down this time. So let's get the other dots in there, folks. It's going to go as low as -1 and as high as 1. I didn't change, oops, sorry. I didn't change the amplitude. I probably could have or should have on this example, but that's all right. So it goes down like this. This is a very slow graph, but it's still sinusoidal. It's still periodic. It will keep going in both directions. So I'd have to count 1, 2, 3, 4, and I'd get a dot right there as far as how I'm trying to graph this nicely. I'm sorry, I did that incorrectly. Let me try again. Every 4 is when I'm hitting the x-axis. That looks better. There we go. And then it just keeps going. All right, so that is a sine curve that's been flipped over, and there's been a horizontal stretch. Once again, this had an amplitude of 1. All right, I think we have 3 more examples where I'm continuing to mix things up. I've seen some teachers who start throwing this stuff at students right away, and it's never pretty. Okay, there is something new here. First of all, the amplitude is the number out front. That's going to be 2. There's no reflection this time. What is the number in front here? It's still just 1. So the period is still 2 pi. So what the heck is this? You remember what that does? That is a left or right shift by pi over 4. And it's always the opposite of what you see there. So negative, you would think it would be left, but it's not. This is a right. It's called a phase shift by pi over 4. It's called a phase shift. If you've ever heard the term, we're just completely out of phase. Out of phase means like here's a graph, here's a second graph that is identical, but they've been moved over a little bit. They're out of phase. So this is a phase shift. If you've ever, like sound waves that are out of phase would sound like they're maybe out of tune, or you'd start to hear some sort of beats or vibration happening. So that's kind of interesting too to study. All right, so phase shifts mean a left or right. So we're going to shift to the right. So let's think about this. Let's walk through it. Our midline is still the x-axis. I haven't really made too many changes to that. However, instead of starting here, where is it going to start? To the right by pi over 4. So I'm going to go here and I'm going to call that pi over 4. Now if I call that pi over 4, then I don't have a choice. This has to be pi over 2. This is going to be 3 pi over 4. This will be pi, which means way the heck over here would be 2 pi. Right? If you keep going, you need 4 blocks. So 1, 2, 3, 4. Let me zoom in for you. 1, 2, 3, 4. 1, 2, 3, 4. Gets me to right here. So this is where one period is going to happen. All right, so it's going to go up, down, up, like that. All right, let's remind ourselves that, so I'm sorry, I'm actually mislabeled that. So 1, 2, 3, 4, 1, 2, 3, 4. No, I was all right. This is 2 pi. That was right. All right, here we go. It's going to start here. This is pi over 4. Where's it going to finish? It's actually going to finish 1 beyond that, because let me go back here. We got to go 4 here. There's the first 4. So I need 4 more. So this will be, let's see, 8 pi, so 9 pi over 4. I remember students have a rough time with all these fractions with the radian. So if you're having troubles with that, you're not alone. So in my brain, I was thinking, well, this is 8 pi over 4. So I just needed 1 more quarter, which got me to 9. Okay, sorry these graphs aren't quite big enough for this. Okay, so it's going to end there. I'm going to put my dot. Now, and then in the middle, which is right here, is where it hits middle. And then it's going to go as high as 2 and as low as -2. So that would be here and here. And then I can draw in my curve right there like that. So this was a graph that got moved over. Now I could go 2 over, 2 down, and then 2 over, up like this, and just keep going like that. It's a little, sometimes it's easier actually when there aren't all the grid lines there, and then you can make your own grid lines. Okay, so I have 2 more examples. There is something different here. So what do you see that's different? Maybe you didn't notice, but I've got a 2 on the inside. That has to do with my horizontal stretch, along with a left or right shift. Now, you have to factor this. You must factor it. So let me write that down. You have to factor it. So you have to divide the 2 out, which leaves x plus pi over 2. Because what happens when you divide pi in half? When you divide a 2 out, you're left with a half. You could do your distributive property and see that that's still there. -1. So this is sine of this mess with a minus sign out front. So let's walk through all the transformations. 2x equals 2 pi. X equals pi is the period. And that comes from this right here. Okay, the 2x right there. This thing is going to be twice as fast as it normally would. What about the amplification, the amplitude, I mean? The amplitude would be 1. It's not -1. Amplitude is never negative. Okay, there is a reflection. There is a reflection over the x-axis, and that's due to the minus sign out front. There is a left shift by pi over 2. And that's this guy right here. Left shift by pi over 2. And there's also a vertical by -1. So we're going to shift down by -1. So if you recall before, I suggested to you that you draw that midline. So here's the middle of my graph. So this is the first one in a while that was not the x-axis. So there's the midline. We got to figure out where that first dot goes. So let's think about this. Normally it would be right here, but it's going to be shifted to the left by pi over 2. So I'm going to call this, this will be -pi over 2. So it would be right here. But wait, was there anything else? Let's double check. I think we're good, right? We got our left shift by pi over 2, and we have our vertical shift down by -1. All right, so where's this thing finish? Well, remember, the period is 1 pi, so it will finish right here at pi over 2, because if you get out your measuring tool, get out your ruler, that's a full pi right here. That's a full pi. So that means in the middle is where it hits the middle. Now normally it would go up and down like this. However, this is reflected. So it's flipped over that midline there. So there we go, like this. And it just keeps going. Here's all my magic moments, as I call it. And no, I'm not going to break into song for you. There we go. All right, so there's my graph. Don't forget to factor. I had to factor. Embarrassingly so, my first year of teaching trigonometry, I guess I didn't read the textbook terribly well to refresh my memory, and I was teaching the students to shift to the left by pi, and that's not right. You have to factor out the 2 before you can do the shift left by pi over 2. All right, we got one more example lined up, and look, we got just about everything going on here. I would suggest you actually pause the video and see if you can do this. If you can tackle this problem, you can tackle just about anything. First thing I'm going to do is factor. So let me come over here and just say that we are going to take a half and we're going to divide it out. Now, a lot of students ask me, what the heck, what goes here? If you divide a quarter in half, what do you get? You're dividing by a half. Well, we're not actually dividing it in half, we're dividing by a half. So what I always suggest is, if you're not sure, do this. Set it up as pi over 4 divided by a half, because that's what we're trying to do. We're trying to divide out a half. We're not dividing by a half. Or dividing by 2. Okay, we're dividing a half out of it. And then we have the whole keep, change, flip thing. We flip it over, and oh my goodness, it ends up being 2 pi over 4, which is pi over 2. This is pi over 2. Okay, so we have a right phase shift by pi over 2. All right, what about the period? For the period, remember you set that b value. This is that b value. You say 1/2 x equals 2 pi. You multiply by 2, and you see this is a slow graph. This is the period right here, period of 2 pi. We have an amplitude coming from this number right here, amplitude of 4. Amplitude equals 4. What else? We have a vertical. We have a vertical by 4, moving up by 4. And I think that's everything. So let's get our midline. Our midline comes from that vertical shift. Here it is. And we would have to go all the way to here. Oh, I'm sorry, vertical. You're probably screaming at your device here. Vertical was 2. The vertical comes from this guy right here. That's a vertical by 2. I was starting to realize that my graph was going to start going off the grid again, and which was going to be annoying. So that's my line, y equals 2. That's my midline. Now let's figure out where this thing starts. Where does this thing start? Remember, we have a phase shift. It said right by pi over 2. So I'm going to go, this will be pi over 2. I'm going to go to the right and put a dot there. So I've got my my right shift, and then also up by 2. And that got me my first dot. Now I need to travel, because remember what the period is? The period is 4 pi. So this would be pi, which means this would be 2 pi. This would be 3 pi, and then over here would be 4 pi, and then one more block would be a little bit further. So I have to go 4 blocks here. That's where my first 0 would be, and then my next one would be way the heck over here, because this is really slow. Okay, so I had to go pi over 2 past 4 pi. Because if you measure this, it's a full 4 pi. Then this thing goes up 4, down 4. So in the middle, I'm going to go up 4 and down 4. I'm sorry, over here I'm going to go down 4. And I can draw in my graph right there. All right, so it was stretched out, it was slow, it was half as fast. It was half as fast. So instead of pi over 2, it took an entire 4 pi seconds, or whatever the heck it is, to finish. And since it started at pi over 2, it had to end at 9 pi over 2. Okay, or I'm sorry, this would be, my brain is locking up here, so this would be 4 pi, this would be 8 pi over 2, 9 pi over 2. There we go, 9 pi over 2. And it went as high. What was the maximum on this thing? Sometimes teachers will ask you that. The maximum here is 6, and the minimum here is -2. It's how low it went at its very peak and valley. All right, I really hope that this helped you understand the sine curve. So I'll make another video on the cosine curve, which is really all the same stuff, just cosine is shifted over a little bit and has some different magic moments. So be sure to subscribe to my channel. I post quite a few very hopefully really helpful things for you, and you can learn all about all these trig things. I recently posted some of the verification stuff. All right, well, until next time.